All right, well, thank you very much for attending my project, City of Phoenix Open Data Engineering, which is a streamlined ETL data pipeline for the City of Phoenix by myself, Robert Bobby Huck, a data scientist. Over 2.5 quintillion bytes of data are generated every day. Data is created by every click, swipe, share, search, and stream, proliferating the demand for big data analytics globally. Today, with the onslaught of completed corporate and digital transformations, the Internet of Things, and the race to become AI-driven, it is crystal clear that companies need reliable data pipeline infrastructure in abundance to provide the foundation for successful data science initiatives. Right here, we have a graph that shows the volume of data generated, captured, copied, and consumed worldwide from 2010 through 2025 in zettabytes. And as you can see, the growth is exponential. Zettabyte is a one with a lot of zeros behind it. So I want to convert it to something all can understand, which is dollar bills. On this graph, we can see big data revenue worldwide from 2016 to 2027 by three major economic segments: services, hardware, and software. As you can see from the graph, it's growing. And the takeaway from these two graphs is to highlight the need for data engineers. So Phoenix is Arizona's capital. It grew at the fastest rate among Arizona's biggest cities. Among America's biggest cities, vaulting it ahead of Philadelphia to officially become the fifth largest city. From 2010 to 2020, it grew at a rate of 11.2% and increased from 1.4 to 1.6 million. And what we can take away from this is that more people equal more records, which is more data, and highlights the need for more data engineers to wrangle and structure this data for insight. My project objective was to create an automated extract, transform, and load, also known as ETL, data pipeline for the City of Phoenix that pulls financial City Checkbook data from their open data portal and structures it and stores it in a way that teams downstream can quickly apply models for insight and graphically represent that insight quickly and effectively. We're going to pause here for a little bit because this is my ETL pipeline diagram. This is my current status. The three segments highlighted in white on the left. Data began in the City of Phoenix CCAN database, which is a database of choice by local and national governments worldwide. The second journey, after being scraped from the City Checkbook website, the CSV links, was to download those CSV links locally onto my computer. Beautiful Soup was used for that, parsing. After that, the data was uploaded from my local machine into AWS S3 storage. This is really what I would call the first stage of the journey, but really it's the second because it stopped on my local machine first. This is just a initial collection. So you could collect CSV files, XML, it doesn't matter what the type. This is your initial collection part of the journey. And from this point, I would utilize a Spark data transformation and validation of the data before I moved it into another AWS S3 staging container. What I want to highlight is that this entire process has been automated by Apache Airflow. By using Airflow, the pipeline tasks are automated to occur in the correct order and at the time that I designate. So I could scrape and pull data every day, every hour. I could pull it every month. It's really up to me how often I want to do this and perform this pipeline. This next slide shows the next steps in my project. After it has been staged in the first AWS storage container, I'll move it into a second staging container, which would just make it easier to roll back. If something goes wrong with my data push into an AWS EC2 Postgres instance, and it's also possible to diagnose and repair data problems at this point. So I would use PsychoPG2 to insert the data into the AWS EC2 instance that has Postgres on it. And at this stage, the data is structured and organized and in a format suitable for queries. It's also at a point where we can apply machine learning models to it. The final product would be an interactive app with Plotly and Flask, where queries, for example, particular date ranges could be conducted, and also you would have the display of machine learning model results at this point. Particular learning opportunities, the first was that I had to change my strategy. There did not seem to be a coherent process to pull the data via the API, so I had to move to plan number 2, which was scrape the data with Beautiful Soup. The second learning opportunity was due to improperly storing my AWS connection credentials so that they were uploaded onto GitHub through a SciCache file. So I learned that there's a best practice AWS config method to store your connection credentials. The last learning opportunity was understanding that the security for your RDS Postgres instance that is hosted natively in the cloud, it's strong, and it was so strong that I couldn't communicate with it. So that's an opportunity for me to dive in and try to figure out why I couldn't communicate with it and learn from that. I want to give a shout out to the following tech stacks for assisting me in my project. And in summary, in closing, this is essentially what I did with my project, was take the data from one spot and pushed it somewhere else. My contact is on the left. If you have any questions, please feel free to reach out to me. And thank you very much for your time.